Hello everybody on your day 4 of notes of NRSR 21 math. Today we're going to be showing you how to remember your percentages as well as using those percentages and how to convert them from decimals to percent on the left side. And on the right side we're going to be displaying how to turn percent into decimals right over here. And then on the next few problems, and then we're going to have possible questions involving percentages in the real with these 5 examples that we'll be walk through together. And then right afterwards, trying to go through some more examples of how you can solve them and understanding what the display of change of percentages or the ounces or any kind of units that needs to be done. And then for the insulin dosages, we're going to show you how to properly fill them in, as well as how you can do that, and also show you more examples of how you can do it yourself. So let's start with turning decimals into percentages. So doing so, all we need to do for these examples right over here is multiply by 100 to move the decimal place over twice that we have right here, so we can get our percentage, which will be 25% for the first example. And then same thing with the other one right over here, multiply by 100 to get 172% for your second example. And then for your last example right over here, you just move the decimal place again over twice, multiplying by 100, then you get 0.9%. And then on the right side right over here, we're going to change the percentages into decimals. Now to start off to do that, now we need to divide everything by 100 so we can have decimal places moved to the left. Doing so, if we divide by 100, we have 0.72 right over here. Same thing with the other one, divide by 100, divide by 100. And you have 1.21, and put a decimal place right there. Same thing with the other one, now you divide everything by 100 to give yourself 0.0009 as your first decimal place. And then for your next examples, for your possibility questions involving percentages in the real world, I'm going to show you how you're able to solve these by just simply using the examples right above to find your answers. So in this case right here, we have a client that reports to have drank 40% of her 12-ounce can of ginger ale. How many ounces did the client have? To start off this problem, we need to convert the percentage we have right here of 40 into a decimal and then simply multiply it by the 12 ounces of can of ginger ale she had. So doing that, we have 40%. Actually, you want to divide, not multiply by this. So we divide by 100 to get 0.4. Now we simply multiply by 12 to get our answer of 4.8 ounces that the client has drank. And then for the second example, we have at the first prenatal visit, a client weighed 140 pounds. At a second visit, the client had a 5% weight increase. How many pounds did the client gain? So to start this problem off, we want to be able to figure out what the starting point is. So we have 140 pounds, essentially. And now we need to add the multiplication of 140 by the percentage of body weight into a decimal to get our final answer. So now we have to change our 5% into a decimal by simply dividing by 100 to get 0.05. So then we have 0.05 right over here. And then now we need to now we had to do addition of doing that. So then we have 147. But we know that the original weight was 140. So simply we just need to subtract by 140 to show what was left, how much they gained. And then we have 7 pounds that the client has gained since that last appointment. And then for your third problem, in a portion of turkey that is 150 grams, there are 23 grams of protein and 4 grams of fat. Now we need to find the percentage of turkey is protein and what percentage is fat. To start off this problem, we're going to need to figure out the percentage of the turkey's protein by simply having the original amount of protein, which is 23 grams, and setting it equal to the whole weight, the weight as a whole of the turkey by 150. And I'm going to put X as our factor, as in to find the percentage of which the turkey is made out of protein. So simply doing this, all we need to do is divide everything by 150. As soon as we do that, we get our percentage of 15.3%. Now we have to fill it in right over here, so we have 15.3%. And then to find the percentage of fat, we simply do the same thing where we have the original amount, 40 grams of fat, equaling 150, X being the percent that we need to figure out what is the percentage of the fat. And then now we just divide everything by 150. To get a percentage of fat equaling 2.66%. And then for a client's medication is increased from 400 milligrams to 500 milligrams. What is percent of increase in the dosage? Now we have the increased amount from 400 to 500, and that simply we know is a 100 milligram difference. So simply we have 500 minus 400 milligrams to get us 100 milligrams. Now setting it equal to the original amount, 400, X being the percentage of increase. Now we have to simply multiply everything by 400. And then we end up doing the whole problem. We end up with 1/4. 1/4 being divided again, where we get 0.25. Now to convert it to percentage, now we should multiply by 100 to get us 25%. Oops. My apologies for that. And then for the number of capsules a client received each day has decreased from 3 capsules each day to 2 capsules per day. What is the percent of decrease? So again, same thing with the last problem. We simply have to show the decrease of that. So we have 3 minus 2 equaling to the original amount, 3x, x being the percent of the percentage that we're looking for, or the missing factor as the previous problems as well. To do so, now we just have to have 1 equaling 3x, and that is going to be equal to 1/3. 1/3 is going to be equaling to x. Now we need to convert 1/3 into a percentage, which will simply be x equals 33.3%. We do that by having the decimal 1/3 be converted by multiplying by 100. Now to move on to the next few problems, we're going to have more examples for you to try. So for the first problem, the infant consumed 55% of formula. How many ounces of formula did the infant consume? Now we want to do is change or change our percentage right over here and convert it into another decimal, so 55% right over here. So now we're going to change that into decimal by simply, like the last few problems, divide by 100 to move the decimal place to the left twice. So we have 0.55 times the 8 ounces, which is 8 ounces. And then now we set that equal to the actual amount, which will be 4.4 ounces. Circle that to finalize your answer. Same thing with the other problems, underlining or doing any other ones will also work. And then for the second problem, we have a client's weight before dieting was 300 pounds. After a month of dieting, client's weight was 240 pounds. What was the percentage of decrease in the client's weight? So now we have a similar problem from the last, like the last one, like number 4, all the way in the top. So now we have the original amount, 300 pounds, subtracted by the amount that the client, by the weight that the client is at the month after where the client was dieting. So we have 240, and then we set that equal to the original amount of pounds, x being the percentage, or the missing factor of what the client, how much the client has decreased its weight. So then we have 60 just from 300 minus 240 equaling 300, divided by 300 both sides to get us our decimal, which is 0.20. Now we multiply by 100 to get our percentage, which will be 20%, which shows our percentage of decrease that the client has lost in its weight. And then for number 3, a client's pulse rate increased from 80 beats per minute to 120 beats per minute after exercise. Now we have to find out what is the percent of increase in the client's pulse rate. Same thing we wanted to do is multiply. We want to do 120 subtracted by 80 with the original amount minus the current one. My apologies. The new one subtracted by the original one. Then we have the original amount being original amount being 80, x being again the factor that we are trying to look for with the increase of pulse rate. So what we want to do now is subtract 120 from 40, from 80 to get us 40, and then set that equal to 80x, divide by 80 on both sides to get us 40 over 80 equaling x. And then now we have to figure out how we can convert 0.50 into percentage by simply multiplying by 100 to get us a 50% increase in the pulse rate of the client. And then for the next problem, we have a client has third-degree burns covering 22% of the surface area of their body. If the client's surface area is estimated to be 1.68 square meters, find the size of the burn. Now, to find the size of the burn, we have to again change our percentage right over here, 22%, into a decimal by multiplying by 100 to simply give us 0.22. Then multiplying by the estimated amount, which will be 1.68 square meters, to get us 0.37 meters squared, since you multiply the units together, of which how big the size of the burn is. And then for the next section we have right over here, we're going to figure out insulin dosages by simply figuring out how much dosage you need in every kind of third of the needle. So, doing so, we have 40 units subcut in AM half hour before breakfast, available Humulin are labeled U-100. Now we have to simply shade the syringe below. Doing so, we have 40 units of subcut from the Humulin RU100. So we just need to simply fill it up all the way to 40 right over here. Pardon me with that shading. You want to go all the way to 40. My apologies, it's not to scale, but the idea is still there when you want to go all the way to 40. Now you want to do the same thing for the other problem, but we have two different kinds of dosages we want to use, since we have 18 units of regular U100 subcut and 20 units of subcut of NPH U100. Now we have to simply add the 2 units together, 22 units. To the 18 units, we have 18 plus 22 equaling 40. Now we again shade it all the way to 40 as our dosage. Right over there. And then we're going to do the same thing with the last few problems, where we have, again, similar problem number 2 as our first example, where we simply add 26 units to 17 units of the first order, which is Humulin RU100 26 units subcut, and Humulin NU100 17 units subcut daily. So, to do so, we shade in the units that we need by simply 26 plus 17, which will be 43 units needed for this dosage. And then we go all shade it all the way till 43. Right there. And then now we're going to do a similar thing with the other problem, where we just simply fill in what's needed for the actual dosage of Humulin 7 out of 30 U100 20 units subcut half an hour before breakfast. Now we just have to simply just shade in to 20. Thank you everybody for tuning in to this day 4 of notes. Let